Very good evening to all of you, and I welcome once again to another episode of Eclectica the Different News. Today is World Health Day, and this time the theme of World Health Day is Health for All. And when we're talking about health, some disastrous disease that we are all scared of is cancer, and we all know that. And the spread of cancer is called medically called as metastasis. Well, I have a very interesting guest today to present to you here at Eclectica, and he is working in a very fascinating field where he has come up with a probable solution, perhaps to stop the growth of cancer or to rather stop metastasis. So, I call in my guest today, Arnab Chowdhury, and he is the founder of Mestastop Private Limited. So we will have a fantastic conversation and stay tuned with us. And if you have any questions, please feel free to put it in the comments and we will take it up as we go along in the conversation. Welcome, Arnav. Good evening, and thank you so much for accepting my invitation today. And thank you for being on Eclectica.
Thank you, Garge. It's my absolute pleasure to be here on your podcast. I was looking back to your multiple guests. You have quite a fantastic mix, and I am honored to be part of this list now. So, really happy to be here. Thank you.
Thank you, Arnab. So, Arnab, we have a lot of things to talk about, and first of all, my question. I mean, how this name came up to your mind? I mean, Mr. Stop itself is a very is a word which naturally creates inquisitiveness. So, can you tell us about Mr. Stop a little bit and how you came up with this name and the entire concept of your venture?
Sure. So, uh, for the name part, we want to stop metastasis. That is the spreading of the tumor, as you succinctly put it. So now it was obvious to give the name Metastop, metastasis, meta, and then stop, and that is what I was inclined to do. But then uh, I just thought that metastasis is such complex. The biology is very complex, right? It's not easy. So maybe I am giving it a very easy name. And that's not doing the respect justice to how complex this biology is. So I just broke it up a bit more. Metastasis, ME from meta and stasis STA. So that's the word mesta comes from. The S is extra and then stop. And that's obvious. The ambition is pretty clear. We want to stop metastasis, and that's the origin of the name. And as far as the origin of the company, in principle, by training, I am not a cancer oncologist. I am not a cancer biologist. I'm a PhD cell biologist, around 20 years experience post PhD. My training was is infectious diseases, parasitology, leishmania, something that causes Kala-azar, you might have heard.
Right.
And then my postdoc was also in parasitology, in sleeping sickness. But I was always interested towards applied biology, in the sense looking into treatments, understanding the how treatments work. And once I returned to India, I was part of a big CRO for almost 7.5 years, where I actually did drug discovery. And this was collaborative programs with big pharmas. And now these are all in public domain. There was GSK, Abbott, Takeda, and even smaller biotechs. So uh, that is where I learned my drug discovery. Obviously, you have to learn, but I learned from the very good people, the best, big pharma people. And most of my work was on cancer during that time.
Mm.
And I would realize, and later on I can give you a bit more depth as to why. But I realized very soon that, and maybe coming from a field outside of oncology helped me understand the fact that cancer is a very evolutionary disease, right? The cells are growing and growing, and as soon as you start killing these cells,
Mm.
somehow some remnant surviving cells changes their DNA code and and survives, right? Just like we are sort of parasites, cancer to this world, and we are killing it. So the only way to stop cancer has to be something very different, something that looks into its weaker spot.
Mm.
So in my journey to find that weak spot, I came upon metastasis. And
Mm.
that is not weak, though, because it is actually responsible for 90% of cancer deaths. However, there is
Correct.
certain reasons due to which we think this is a weak spot, and that brought me to metastasis. And then it was just a no-brainer that this is what I wanted to do. Having said that, it's not easy. You have a very good job, and then I moved from that CRO to I moved to a MNC Amgen. It's a one of world's number one
Yes.
biotech. They were opening up something here in Bangalore. I moved to Bangalore, and but I mean, eventually I bite the bullet. So that's it. That's how Mestastop happened.
Fantastic. So I think your journey itself is an inspiration. So I think we'll talk more about the things that you do. Arnab, what do you like a person from the industry and having such a didactic career, and now you are you have stepped into your entrepreneurial journey. So like from an academician point of view, I'm asking this,
Hmm.
that if anybody, any fresher or who are aspiring, who look up to people like you, so if somebody wants to step into this kind of a career path or coming to the industry per se, so what do you think are the most important skill apart from their professional or academic skills they should acquire so that they get fit inside this kind of an industry?
Okay. So let me dissect it into two parts. First part would be the skills that would be required to migrate from academia to industry, and the second I will focus on the skills if somebody wants to start something on his or her own, right? So the first part, I think, see, end of the day, even in industry, uh, it's science that is the platform, right? Whether it's basic research, you are trying to understand the biology. In industry, what you are trying to do, you are taking the biology that has been explicitly understood by somebody else and trying to build on that. So
Right.
end of the day, you are a scientist. But having said that, industry helps you to train your mind in much more focused way, because it just makes you look at not only uh, you know multiple problems, but maybe one problem in a very
Yes.
multi-dimensional way. And for that, I think key is you need to be a very good team player, because what happens is many a times in academia when you are doing PhD and all, one is reading on their own, one is doing the experiment single-handedly. So you
Right.
are not trained so much to be a team player, as at least here in India, right?
Correct.
But industry is all about being a team player.
Hmm.
It's all about being a team player where multiple people are bringing in multiple ideas and executing them together simultaneously. So you have to leave aside your ego, because we scientists, we have ego. I mean, what does he know? I know the best, right? Things like that.
Right.
So you have to keep that aside. You have to
Hmm.
keep that aside, and you need to be humble, and you need to acknowledge that you can also be wrong and the other person might be right, and you have something to learn, right?
Hmm.
As long as you have that mindset, I think the sky is the limit. And for the later part, the second question, the skill sets to be an entrepreneur, honestly, even now after 5 years, I don't know.
You don't
because
know.
because see, I mean, it would be false to I can give a lot of gyan, but I don't want to do that. Because see, the truth is, when somebody becomes an entrepreneur, right, I can say for myself that
Hmm.
most of the time we follow our heart, right? you
Yes.
you and especially in
Correct.
technical fields, you have an idea, you think it's groundbreaking, you are not getting the scope to pursue it, and you
Hmm.
want to give it a shot, right? So it's all heart and very little brain, and thank God for that, very little brain, because otherwise I probably wouldn't have taken this plunge.
Hmm.
So
Hmm.
then what to preach, right? Because I was a scientist, I had no commercial background, I didn't understand economics, I didn't understand all these things, right? But I
Hmm.
was very lucky having a school friend of mine called Praveen Agarwal, who is a successful chartered accountant, company secretary, and we used to
Okay.
go back all the way in school. We were last benches there. So Praveen, and we were not in touch for 25 years. He reached out to me and said, "Boss, you are doing something great. It's very exciting. I want to
Hmm.
be a part of journey. So from that day onwards, I just focused on the science, and he focused on the compliance, the finance, and he brought in other people who took care of everything. So what I'm trying to say is, you need not tick all the check boxes. If your
Correct.
heart is in it, you go ahead, you take the plunge. And if you are really passionate, if you have that self belief, if you are sincere, the universe will make it happen for you. So it will work somehow. Kam ban jayega. You just go for it. Having said that, I am not there yet. So we have miles to go, as you know, Mestastop. So it's not that I have reached a place and I'm saying this. So
Hmm.
I also have a lot of struggles left. But I think self belief is the key. As long as you believe in yourself, you can turn all the odds against you.
Thank you, Arnab. That was very powerful and very inspirational message, and very practical thing that you told. Because I think just giving some, as you said, motivational speech or giving some points of inspiration doesn't help. It's the reality that we need to understand in each of the field. And ego, yes, I do agree. Even medical professionals have a lot of ego that, oh, we are doctors, but I think entrepreneurship just reshapes you from scratch. I mean, you become a new person altogether. So, Arnab, I went through Mr. Stop's website. So, and I saw that there are two, three platforms. So, are these products or these are services? So, if you can elaborate one by one on that, it will be very nice to know.
Absolutely, absolutely. So I think that's why I'm here. I would love to talk about Mr. Stop. And the
Sure.
good part is, see, my it is Mr. Stop is like my spouse, and my spouse doesn't complain because she is also part of Mr. Stop. So we are co-founders, and me and Devovani, we are running it together. So
Wow.
whether I am at work or some days when I'm like home like this, I'm
Hmm.
always thinking of Mr. Stop. So I love to talk about Mr. Stop. In fact, you have to ask me to slow down or shut up. So please feel free. So what we did was, see, very soon as I realized, I'll take the graph from that evolutionary part. Cancer is an evolutionary disease. So just to give you an example, the first kinase inhibitor, imatinib, that was approved in early 2000. Today we have the fifth generation of imatinib, and still you have treatment-resistant patients coming up within 4 to 6 months. And if you try to understand the science behind it, we do realize that the initially the patients respond, but then all of a sudden certain mutations comes up, right?
Okay.
And these mutations are then not treated by this disease. So imatinib had mutations, had resistant mutations that brought the second generation, third generation, fourth. Today we have fifth generation. All I'm trying to say is, no matter what medicine you give, it only works for a few months. Why? Because the
Mm.
cancer is dividing, and some cells are mutating randomly and selecting that mutation which can bypass that treatment. And the mutation
Right.
is in as simple as one amino acid. One amino
Correct.
acid. People later on, people came up with covalent irreversible inhibitor, something a drug called ibrutinib, which targets enzyme called BTK. So ibrutinib BTK worked for 6 months, then it stopped because that particular amino acid where that inhibitor was binding was mutated.
Mm.
So the point is, no matter what you do, cancer figures out a way, and that is, it's not magic. It's simple, plain and simple evolution. So obviously, that search brought me to metastasis, where I realized that this, and this is very interesting. See,
Mm-hmm.
cancer. When you think of cancer, what is cancer? It is uncontrolled proliferation.
Yes.
What is metastasis? Metastasis is again uncontrolled proliferation, but in a different location.
Correct.
Now the question is, how does this journey happen? Do a
Mm.
bulk of mass, a mass of cells, move
Mm.
from one part of the body to the other? No, they
Mm-hmm.
don't. So what happens here is, 90% of the cancer cells are involved in proliferating. A few of them, 5%, maximum 10% of them, they don't focus on proliferation. They start their movement. So
Right.
they are the nomads. They start their movement, and they move through mostly through the blood,
Yes.
going to a secondary tissue, and then they stop their movement. Now, see, if I give you a glass of glucon D and
Mm.
you drink it, you have enough energy that will make you run for 20 minutes, or
Correct.
you can walk for 40 minutes, but you cannot do both simultaneously. So same is the case for cancer cells. They have limited energy, right?
Mm.
And
Mm.
they require energy all the time, because there's so much growth parameter involved. So the cells that are moving, they cannot afford to lose energy growing, which tells you that the proliferating 90% proliferating cells are very different from the 10% cells are moving. Now, if you look at treatments, what are we treating? We are treating the proliferating tumor cells, primary tumor or the secondary tumor. We are not treating the cells that are metastasizing, because these are the moving cells. And when you take out the primary tumor, you don't see many much of the moving cells, because most of them are in the blood or they are hiding in the secondary tissue. And
Mm.
again, in the secondary tissue, these moving cells again changes and grows back to growing cells, and then starts forming the tumor. So you have a growing cell, you have intermittent moving cells, again you have growing cells. So how do you treat metastasis? You have to treat metastasis by targeting these moving cells, which are hard to catch. But what we realize that these moving cells do
Mm.
not replicate, right? They hardly replicate. Their growth prowess is very less, because they are spending that energy on movement. And you
Movement.
don't want to grow from 1 to 10 in blood. Instead, you want to get out of that place and go to somewhere safe, right, and
Correct.
hide there. So if one can target these moving cells, what is the probability that they will bypass this inhibition by
Mm.
proliferating and selecting mutations? Anyway, they are very weakly proliferating. So they, though being the strongest part of cancer, they can be the weakest link. So that is what brought me to metastasis, right? But
Fantastic.
I was shocked to see that, and or realize the fact that 90% of cancer deaths are due to metastasis. I mean, that is shocking. And then you realize the further shock, the next
Mm.
level, is there is no drugs to treat metastasis.
Yes.
Whatever drugs you have, from chemotherapy to all
Mm.
precision oncology. Again, I am repeating myself, all precision oncology medicines, immunotherapy, they all
Mm.
treat the secondary or the primary tumor. They do
Yes.
not treat the process of metastasis, that is the movement of the cells.
Mm.
So how do you beat that? And it is very challenging, because previously people used to think that the
Mm.
tumor, if it's as big as an apple or orange, only
Mm.
then it can be treated. But nowadays we know that the tumor can be as big as an apple or orange.
I think we have a connection
Hello.
problem. Yeah, yeah, Arnab, you are back now. I think it got freezed for some
Okay.
time. Yeah.
Okay. Sorry. So where was I last? I was talking about the tumor size, right?
Yes, like a
Yeah.
apple, if it's like
Yeah.
apple
Yeah.
or
Right. So even if the tumor is as small as a peanut, it
hmm.
can still move. So now imagine the scenario that when you are giving a treatment for primary tumor, surgery done, chemotherapy being given,
Hmm.
one would think that, okay, the main mass is gone. But if it was spreading cells, even when it was much smaller in size, now there are cells in the secondary tissue. And the sensitivity of PET scan is you need at least 10 to the power of 9 cells. 10 to the power of 9 cells to visualize under PET scan, or 10 to the power 5 cells to visualize in liquid biopsy. So even if you have 90,000 tumor cells in a secondary tissue, you are clinically, there's no cancer, right?
Yes,
Which is
right.
incorrect. We can't see it. So
Hmm.
these cells in the secondary tumor, in the secondary tissues, can come back all of a sudden, and that is why many a times you would see that the patient was fine, the chemo worked, surgery worked, tumor came back in a year, in a two
Correct.
years, sometimes even as long as 10 years, right?
Yes.
So because uh, cancer is actually hiding, it's there.
Hmm.
So sorry, I mean, this was quite a bit of the context, but unless I would have given it, it would be hard to difficult explain the platforms. So now I come from a drug discovery background, right? And in
Hmm.
drug discovery, you start with thousands of molecules, you do
Yes.
efficacy, then you also try to understand drug like properties, which we call ADME PK, that is what the body does to the drug, and then how the drug reacts in the body, PK, PD, and finally you take some into patients, right,
Hmm.
in the safety for clinical trials. So now think of metastasis. If we do not understand the biology of metastasis, because we are thinking that initial coming out of the cells is the main area to focus, but now
Hmm.
in hindsight we know that when we are going there, because unless you see tumor under PET scan, right, nobody would go and normally do a PET scan every 6 months. Nobody does that,
Absolutely.
right? That's not
Yes.
feasible. That's not healthy either. So unless you see something in the PET scan, why would people do a liquid biopsy? People won't, right?
Correct.
So by the time you detect the cancer, be rest assured some cells are spread, right? And then it's your luck or your chance or whatever, your genes, your immune system, whether it will metastasize or not. That is
Hmm.
whether it will grow back or not. So now we, as discovery scientists, we realize that there has to be other steps which are later in the part of the metastatic biology cascade that are
Hmm.
responsible for metastasis, and we don't understand these steps, and that
Hmm.
is why we are unable to come up with any drugs for this, because how are these steps relevant? We don't know that. So this is from where our first platform comes. What we did was we envisioned metastasis biology in our own understanding, and we broke metastasis, as I said, it's a very complex disease, into 30 small single steps. So imagine a ladder. The
Hmm.
total ladder has 30 steps. So from the bottom to the top is the process of metastasis, but it doesn't happen in one jump. You have to
Right.
take step by step and go up the ladder. So that's how we created these 30 steps. We call these assays, biological assays that we do on the bench. So now what
Okay.
are these assays? We are looking into the basic things that everyone has looked at. That is
Hmm.
how the cells are moving out from the primary tumor, invading through the epithelial membrane. But then we asked more questions: how the cells are moving through the blood vessels or the lymph nodes, how they are surviving in the blood, how they are moving out of the blood. And the biggest challenge is after that, when cells move out of the blood into the secondary tissue, right?
Hmm.
So
Hmm.
many things can happen, right? Your body has a fantastic immune system. Otherwise,
Correct.
all of us would die of cancer by the time we are 20. We don't,
Correct.
right?
Yes,
So the
absolutely.
body's immune system takes care of that.
Hmm.
So how do you evade that immune system? There are
Hmm.
other apoptotic machinery in the body that will kill these foreign cells. And the worst of all is, even if they don't, right? Imagine, a vegetarian person, a
Hmm.
Gujarat vegetarian guy coming to a place where it's all non-veg food. Hmm. Only fish and meat, nothing else. There's no
Hmm.
sabji, anything. So
Hmm.
how does that person survive?
Five.
He will
Hmm.
die of fasting unless he adapts.
Correct.
Similarly, this tumor cell that came from the colon, now it is in the liver, is in a very, very foreign environment.
Yes.
And it will die of starvation. It will die of malnutrition unless it adapts. So how does it adapt? It can adapt in multiple way, as in changing the eating habits, which we call change in metabolism. So we are
Hmm.
looking into multiple aspects, that is immune, the how they evade the immune system, these few tumor cells, how they evade the apoptotic system, how they adapt in their metabolic prowess, right? And also how they crosstalk with other cells, and this is done by secreting small vesicles out of the tumor cells,
Yes.
and also taking up vesicles from the neighborhood cells. So this is called exosome secretion or exosome uptake.
Yes.
So these are all facets of biology that are explored differently and independently, but not in the
Yes.
context of metastatic biology. Right. So it's not
Correct.
that we have invented new science. No,
Hmm.
we have just aligned different small pockets of science, thinking that this might play a important role in process of metastasis. Because what cancer has taught us, cancer is nothing but a very good hijacker. It hijacks your body's systems, whether
Correct.
it's a response to lack of oxygen or a response to stress. It hijacks all those systems. So
Hmm.
now that we have created these 30 platforms, we can test how a patient sample behaves in these platforms, and how a drug can act on this platform. To give you a bit more context, so now you
Okay.
have 30 steps for to understand metastasis. Hmm.
Okay.
However, I said that metastasis is about moving cells and tumor
Yes.
is about proliferating cells. So, our first question was, can we differentiate how the moving cells behave and how the growing cells behave in this 30 step assay, right? So now,
Okay.
see, whatever tumor cells you get from patients, these are
Hmm.
mostly surgery samples. These
Yes.
are mostly growing cells. There will be some moving but very few. So how do you
Correct.
characterize thousand moving cells out of 100,000, right? It's very
Hmm.
difficult.
Hmm.
So we created genetically engineered moving cells out of growing tumor cells. And then we characterize these moving cells and the growing cells on this assay platform. So now for each assay, as for example, exosome secretion or
Hmm.
platelet binding in the blood, we have a x-axis, that is how the cells will behave if they are
Okay.
growing, and a y-axis, how the cells will behave if they are moving. Okay.
Hmm.
Now, if we take a patient sample, we take patient's tumor sample, we isolate the tumor, grow them, and run them on our assay platform. The
Mm-hmm.
patient samples behaves somewhere between how a classical moving cell will behave and however a classical growing cell will behave, because they are all it's a mixture of population, 90%, 10%, but still it's a mixture,
Hmm.
right? Now, in some of these assays, the patient cells are more inclined towards growing, and in some more inclined towards moving, and in some completely neutral. So, how do you understand that among these 30 steps, the patient samples behaving different ways in different steps? What is the summative nature of the patient sample to grow or move? You can't, right? As a biologist, independently looking at the data, you can't. But thank God, now we have fantastic machine learning engineers
Hmm.
who can take all this data, feed
Hmm.
into multiple types of algorithm. God knows how they do it. I don't understand, but end of the day, the results that comes out, of course, with due statistical significance, uh, those are meaningful. And from there, what we could do was we could identify that out of these 30 steps, 8 steps are very critical for the success of metastasis.
Hmm.
And among these 8 steps, you won't believe me, that initial invasion was there. But there are 4 steps that are in the secondary tissue microenvironment, which defines the success of colonization. And
Okay.
that makes sense, because
Hmm.
the single cells, they are hiding in the secondary tissue. Either they will die, or they will survive, but they will not grow, and they are looking for the right opportunity to grow, right? Or once they start growing, you have the metastasis. Hmm.
Correct.
So this is the platform. The first platform is the assay platform, METAssay, that we created. The
Hmm.
second platform is we take the patient samples, run it
Hmm.
on this assay platform, and we get the data, feed it into the algorithm, and we can do two things from that. We can predict what is the patient's tumor's probability to metastasize in the future. So we only work with primary tumor patients, patients'
Okay.
tumor potential to metastasize, and also, as I said, we can detect what are the key rate limiting steps, so that as biologists we can target those steps for
Hmm.
further drug discovery. So these are the two main platforms. The last platform is pretty simple actually. We call it METVivo, which is
Hmm.
animal models. So the challenge in metastatic animal models is twofold. Number one is, if you want to mimic the biology, that you
Hmm.
put some tumor into the colon and want to see metastasis into the liver, you have to wait, and by the time you are waiting, the mice will die, because the tumor has grown so big in the colon. So the only way to do that experiment is again take out the tumor, do another surgery to take out the tumor, and then wait patiently to see if that mice shows metastasis or not. So this might take 4 to 6 months. If you take 40 mice, only 5 of them will show metastasis, right? So number one, from discovery perspective, it's a long time taking course, and
Yes.
also you have to take a lot of animals to be statistically significant, which is
Correct.
sort of not feasible in terms of commercial potential, right?
Yes.
The other way people do is they directly inject some cells into the heart or into the tail. So that is
Hmm.
directly into the blood. But then you are bypassing the initial steps of
Yes.
metastasis, right? and the
mm,
cells are trained through that initial stage. So that is also not correct. So what we did was, the cells that we had created, genetically engineered cells, that
mm.
had a higher moving potential, right? So we took those cells, put in them some luciferase gene, and then put them back into the colon of the mice. And
Okay.
now, so we can induce these genes, in the sense, if we give a particular food to the mice, these
Mm.
genes will get expressed, and the tumor will start metastasizing. So we eventually saw metastasis from colon to liver. Instead of 6 months, we could standardize it down to 6 weeks. And due to this luciferase gene, and if you just give intraperitoneal luciferin, you don't have
Yes.
to sacrifice the animals. You just
Correct.
visualize them every 5 days. So the same animal can be
Mm.
monitored over a period of time, right? Which means that if you take 8 animals, and if all 8 of them shows metastasis, then you just need 8 animals. Cost is one fifth, and you just need 6 weeks instead of 6 months. So there the cost goes down. So this is just a increase in efficiency. This is sort of this is not a, a radical change in idea or concept, but I think
Mm.
the only indigenousness here is in using the genetically engineered cells.
Right. Right.
But I would think the first two platforms should be the key game changer. That is the METAssay and the METSCAN.
Arnab, I'm just mind blown for what you said, and particularly the kind of science, the complex science you have broken down and you have presented in such a simple way. I think anybody who know English and they understand English and they hear this conversation, they will understand what it is all about. So
No,
I
I'm
have just
glad. I'm glad. Yeah,
it
please.
is fantastic. I mean, it's as a science enthusiast, I just get that glitter in my eyes. Like, what are you doing? I mean, it's amazing. So Arnab, one question is that, like, is this platform is the are these two platforms applicable for any kind of primary tumor, or it is like specific to a particular cancer?
Excellent question. So the answer is yes and no. So as of now, we have see we we honestly believe that okay. Can I just take a step back, because
Yes.
I want to give a technical proof that is behind our belief. Till
Sure.
now, there have been multiple publications. The last one from Memorial Sloan Kettering, that worked with 25,000 patient samples across 28 solid tumors, and even they did not find gene sequences that would define metastasis. What I'm trying to say is, we know tumor sequences, mutations, gene sequences that promotes tumors initiation, tumor growth, tumor propagation, that is driving the tumor. But genetically we cannot define metastasis. So
Yes.
I was always of the idea that at least for all solid tumors, there
Hmm.
is a common minimal biology of metastasis. That is what I'm trying to say, is the way colon cancer spreads and the way breast cancer spreads, these two cancers are completely different from each other, but there has to be some similarity into their biology of spreading. So
Hmm.
this was the concept. So
Hmm.
ideally, when we started, I was naive to say that, it's for all cancers, but when you come to implementation, you don't have money. How will you do it for all cancers? So we started with colorectal cancer,
Okay.
and we created the platform with colorectal cancer. Now we are working with triple negative breast, and we are also working with head and neck. But
Fantastic.
the data that we have, and this is where we are, it's very encouraging. The data that we
Mm-hmm.
have
Mm-hmm.
from colorectal, from triple negative, and from head and neck, that is, head and neck is your oral cancers, but we are only taking tongue and buccal mucosa,
Okay.
because even pharynx and there's a lot of other tissues there. We don't want to
Yes.
make it too complicated. So what
Hmm.
we are seeing is, yes, we were indeed correct. There is a common minimal similarity between how these cells spread, whether
Hmm.
it's colon or head and neck or triple negative. So I am hopeful that with adequate funding, and probably in 2 to 3 years time, we will
Hmm.
be able to extend this in
Hmm.
multiple tumor tissues, and eventually a decade down the line, we would be able to pick the common minimal that is required for successful metastasis across multiple solid tumors.
This is amazing. I think, I mean, the kind of information that you got out of your experiments, and with the vision, with a simple idea you started. And
Yeah.
because I asked you this question, because being from the healthcare profession myself, the biggest challenge for a clinician, at least I know for oral cancer, I would say that we see a lot of pre-malignant lesions. And to be very honest with you, and it is a true fact and known fact that when we see the patient, we just give them palliative treatment because we don't have anything else to do, because some of the lesions are like that. It's not like we can't take a biopsy just for that kind of a lesion. And it's something like, as a clinician, I feel so bad that we are just waiting for the cancer to happen, because I don't have any diagnosis or diagnostic aid with which I can actually pinpointedly at least see the prediction that whether this is going to be, it has any metastatic potential or not. Because by the time the patient again comes back, something has happened, because we give palliative care. And I mean, so this juncture, I think this kind of problem might be there in other field of tumors as well. So that is where I feel that your technology is very promising, as you said that it would be like it can give predictions whether it has a metastatic potential or not. So I think it is something, it is a very groundbreaking work. And I'm sure that is just a matter of time, and I think
Yes. So
it will be
that part,
fantastic.
Gargi, is very important. Thank you. Time. So just because a lot, whoever is listening, uh,
Hmm.
God forbid, maybe they have some cancer patients at home. So
Hmm.
see, as scientists, and of course it's a biotech, so now I am also a businessman, but I'm wearing the hat of a scientist here today. So all I
Right.
want to say is this comes with a lot of responsibility, right?
Yes.
This comes with a lot of responsibility. So I want to give hope, but I don't want to give hope that we are ready as of today,
Hmm.
right?
Hmm. Hmm.
So I will tell you why. Because in terms of drug discovery, we have
Hmm.
understood what can be the four key steps, and we have enough data of clinical significance to
Hmm.
address these steps and targets. And as we speak, in coming fortnight in the American Association Cancer Research, we are going to present our first in class first target for metastasis.
Fantastic.
So we know we are there. But in terms of the prediction,
Hmm.
we are running clinical trials, right?
Right.
So the
Right.
first set of clinical trials, we are in collaboration with Rajiv Gandhi Cancer Hospital in Delhi.
Hmm.
And in the first set of clinical trials, whatever patients we have assessed, uh, we have made certain predictions where we all our there has been no false negatives, which means that there's not a single case where we have said this will not metastasize and the patient has
That
metastasized.
happened.
No, that
Hmm.
has not
Okay.
happened. And there has been 5 matches where we have said the patient's tumor will metastasize and it has metastasized, right? And
Hmm.
there have been quite a few false positives as of date where we have said this will metastasize but it hasn't.
All
and
right.
uh, and it can be a false positive, or god forbid it might metastasize in 6 months down the line and prove us right. But what
Hmm.
I'm trying to say is, in order to do a bigger clinical trial, we need to first complete this data. and
Correct.
and and the way our platform is now, we need at least 400 to 500 milligram of the patient's tumor to get the enough amount of cells. So now the good news is we are almost there to close a fundraise where we can actually scale this down exponentially and can make it a much higher throughput, so
Hmm.
that the example that you just gave, because
Hmm.
you are reluctant to do a surgery, and unless you give us a significant amount of tissue we can't do that. So we
Correct.
can't help these people as of now, but once we can scale it down, once we can make it high throughput, maybe a very small needle sample can be enough to help us understand the properties of the cells. But to be honest, we are still a bit far away from there. So that's why I wanted to make this point that there is hope, but
Hmm.
we are still not ready yet.
No, I think that that's a very honest, honest thing that you told. But I was just trying to see. I mean, it's a very visionary work that you are doing, and if it is successful, I mean, I'm sure it would be. So it is a game changer. Whether you are going in drug development or you are, kind of building a platform, at least a prediction facility. So I think as a clinician, when we if we get access to this kind of diagnostic aid, it is very important, because we are daily dealing with people, not animals, and
Absolutely.
so that
Absolutely.
satisfaction, and we can actually change the entire life, everything of that particular patient. So on one question is just running through my mind just while you were explaining, like, you talked about exosomes, and you talked about, like, taking a cell. It's just like a futuristic question maybe. So in case these platforms, like the type of results you're getting now, you're using cells, like I mean to say, it is mass of tissue. So since we also have exosomes, or shedded cells inside saliva in our mouth, so is it possible that we can use saliva as well for extracting, as a sample to on this platform? Because I am asking this because I am kind of saliva enthusiast.
No, no, I
Yeah.
understand. That's a fantastic question, and I would never say no for an answer for something which I don't know myself, right?
Mm-hmm. Mm-hmm.
So as of today, we cannot do it, but
Okay.
the way science is progressing, the way technology is progressing, you never know what might happen in another 10 years. I'm not
Mm-hmm.
saying even 25 years, another 10 years, this is possible. And to be very honest, I have had team members in Mestastop who actually have been talking about saliva and urine, and I refrain from it. I will honestly admit, because with limited budget, you must have
Yes.
a very sharp focus. But
Correct.
as and when we grow, and we would definitely explore this. But if anybody else is listening and they have the means, I think
Hmm.
this should definitely be explored, because this then makes it much more efficient, simpler, and quicker.
Yes, yes, yes. So I think that was wonderful, Arnab, knowing about Mestastop. And I think just to conclude this conversation, I will not hold you for longer. But for me, as a science enthusiast, I can listen to you for hours together.
No,
So
no, you are welcome. Come over to Bangalore, give me a ping. We will catch up over coffee and we can discuss.
definitely,
Yep.
definitely, I would love to do that. So, just before you go away, because we have a very versatile audience here, and we also have, fresh aspirants who look up to this kind of conversations, and when industry experts like you come and talk. So, just that one, what would be your message for freshers, or like whether they are coming from healthcare professional or life sciences, when they want to, get into the a career path? So what would be your message for them? So, like you have an extensive academic career. It's very versatile career, and then now you are doing what you thought of. So how can some, is it like somebody should plan it before, or how is it, how a new person can actually visualize a career path? That would be, what would be your message in that way?
So that's a very interesting question, because I need to answer this very responsibly. Because see, myself, when I finished my grade 12,
Hmm.
I had no clue what I wanted to do. I just knew that I don't want to become an engineer or doctor. So I didn't appear for joint entrance and IIT examinations. At the same time, I had no idea what I wanted to do. So I got admitted in commerce. I got
Hmm.
admitted in statistics. I got admitted in chemistry. And I actually started as an English honors graduate. And after a week
Okay.
of English honors, I realized that is not for me. And then I moved on to chemistry. So
Mhm.
and then to biochemistry, and then I fell in love with these subjects, and then it was easier. But what I'm trying to say is, you know everything need not be planned.
Right.
But when I see my elder daughter, who is in college now,
Mhm.
she knew from grade 3, 4, or 5, somewhere down that line, that she wants to become an environmentalist, and today she is pursuing that. right?
Wow.
So there had never been a second thought. So these are the two extreme uh, uh, spectrums of the rainbow, right? So anything is okay. There's no written rule that it has to be like this, it has to be like that. The only thing I believe is, end of the day, see,
Hmm.
what matters, and this might sound a bit odd, what matters is your inner happiness. That can
Yes.
come from your job, that can come from your hobby, that can come from money, that can come from anything, right? So whatever gives you happiness, pursue this. And as George Bernard Shaw had said in Pygmalion, happy is the man who earns his living by his hobby. So if you can do that, and I am today very happy, I earn very less, but I am pursuing my hobby. So, I am really happy. So I think happiness is the key, number one. Number two is self belief is very important. Having said that, it's contrary to that, but in science, you need to have that humility. No matter how much self confidence you have, you must also have that humility to admit that I don't know everything. I have to learn. And a 22-year-old can teach a 49-year-old like me something. So as long as I'm open to that, sky is the limit. So that should be the mentality for each and every youngster. And I must say that in this entrepreneurial journey, uh, I have seen so many young people, not from science, but where I was incubated, there was a lot of engineering graduates, IoTs, and AI ML people. These are young people in their early 20s, in their late 20s, right? And they are doing fantastic, right?
Correct.
So who am I to give, give these people tidbits? I mean, I am also learning from them. So
Right.
follow your heart, be honest to yourself, just have some bit of humility and learn, and then there's no stopping you.
Thank you, Arnab. It was fantastic talking to you today,
Thank you.
and I hope we will have more discussions like this, energizing in the near future as well. And I wish all the best for whatever you are doing. It's a groundbreaking work, and I got excited about it. And perhaps I will read more now about whatever you are doing, and I'll learn from you as well. Thank you so much. Thank you for being here. Thank you,
Thank you.
everybody, for joining
Thank
us
you.
today.
Thank you,
Thank you.
Gargi, for giving me and Mr. Stop a chance. We really want to address this issue because the biggest pain in cancer is living between scans. And
Yes.
as a family, we have all gone through that, and we know how painful it is celebrating a birthday and wondering whether that person will be there for the next birthday or not. So it's painful, but we are still not yet there, and we need all your best wishes and blessings to go there. We will give it our best shot. I can promise you that.
I know, and I'm sure that you will reach whatever the point where you want to reach, because it's a very honest endeavor, and I can understand as a passionate entrepreneur myself. I can understand from where it comes, from where all these ideas and your work, your passion, everything comes. So I think it's just a matter of time, and you are doing a fantastic
Touch
work.
wood.
And thank
Touch wood.
you for doing what you
Thank
are
you.
doing. Thank you so
Thank you,
much.
Gargi. Thank you.
Thank you.
Thank you.
Bye
Thank
bye,
you very much.
everybody. Stay tuned and take care. And we'll meet again in another episode with some interesting people like Arnab. Thank you, Arnab. Bye bye. Take care.
Thank you.
Good
Bye.
night.